Hey there, science enthusiasts. Welcome back to our channel. Today, we are diving deep into the fascinating world of science to explore 8 mind-blowing mysteries that continue to baffle scientists around the globe. Don't forget to hit that subscribe button and ring the notification bell so you never miss an update on the latest scientific discoveries. Let's get started. Number 1. Dark matter. Dark matter is a mysterious and invisible form of matter that makes up a significant portion of the universe's mass and gravitational pull. The mystery surrounding dark matter arises from several key observations and questions. 1. Unseen mass. Observations of galaxies, galaxy clusters, and the cosmic microwave background radiation suggest that there is more mass in the universe than can be accounted for by visible matter, stars, planets, gas, etc. Dark matter is believed to make up about 27% of the universe's total mass energy content. 2. Gravity without a source. Dark matter doesn't emit, absorb, or interact with electromagnetic radiation, such as light, which is why it's dark and cannot be detected directly. Yet, its gravitational influence can be seen in the way it affects the motion of galaxies and galaxy clusters. It acts as a gravitational glue that holds galaxies together and contributes to the large-scale structure of the universe. 3. Particle nature. Dark matter is thought to consist of one or more types of particles, collectively known as dark matter particles. These particles are still hypothetical and have not been directly observed. They are expected to be different from ordinary matter particles, example, electrons, quarks, and interact weakly with other particles. 4. Role in cosmic evolution. Understanding dark matter is crucial because it played a significant role in the formation and evolution of the universe. Its gravitational effects helped galaxies form and merge over cosmic time. Scientists are actively researching and conducting experiments to detect and understand dark matter. Various experiments are underway to search for dark matter particles, including those conducted in deep underground laboratories and particle colliders. While we have strong indirect evidence for the existence of dark matter, the full nature of this cosmic mystery has yet to be unveiled. Number 2. The nature of consciousness is a complex and ongoing philosophical and scientific mystery. It refers to the subjective experience of awareness, thoughts, sensations, and emotions that each individual possesses. There are several key aspects to this mystery. 1. Subjectivity. Consciousness is inherently subjective, meaning it can only be directly experienced by the individual themselves. It's challenging to study and understand something that is so deeply personal. 2. Emergence. Consciousness appears to emerge from the physical processes of the brain, but how and why this occurs is not fully understood. This is known as the hard problem of consciousness, proposed by philosopher David Chalmers. 3. Unity. Despite the brain's complexity with its many interconnected regions, consciousness provides a unified and coherent perception of the world. How this unity arises from diverse neural activities remains unclear. 4. Qualia. Qualia are the subjective qualities of conscious experience, such as the redness of an apple or the taste of chocolate. Understanding how these qualitative experiences emerge from neural processes is a significant challenge. 5. Origin. The origin of consciousness, both in terms of evolution and individual development, is still a matter of debate. When and how did consciousness first arise in the universe, and how does it develop in a growing human brain? 6. Relationship to the brain. While it's widely accepted that consciousness is closely linked to brain function, the exact nature of this relationship is still not fully understood. Some theories propose that consciousness is an emergent property of complex neural networks. 7. Altered states. The study of altered states of consciousness, such as those induced by meditation, psychedelics, or sleep, provides additional complexity to the mystery, as these states challenge our understanding of the boundaries of normal conscious experience. Scientists and philosophers continue to explore these questions through various approaches, including neuroscience, psychology, philosophy of mind, and even quantum physics. The nature of consciousness remains one of the most profound and intriguing mysteries of the human experience, with no definitive answers as of my last knowledge update in September 2021. 3. The origin of life. The origin of life remains one of the greatest mysteries in science. While there is no definitive answer, several theories attempt to explain it. 1. Abiogenesis. This theory suggests that life arose from non-living matter through a series of chemical reactions. It posits that simple organic molecules gradually evolved into more complex ones until they formed self-replicating molecules, the precursors to life. 2. Panspermia. Panspermia proposes that life didn't originate on Earth but was brought here from elsewhere in the universe, perhaps on comets or meteorites. This theory raises the possibility that life is widespread in the cosmos. 3. Hydrothermal vent hypothesis. Some scientists speculate that life may have originated near hydrothermal vents on the ocean floor. These extreme environments contain the necessary chemical ingredients and energy sources for life to potentially begin. 4. RNA world hypothesis. This theory suggests that early life was based on RNA, ribonucleic acid, rather than DNA. RNA can both store genetic information and catalyze chemical reactions, making it a possible precursor to DNA-based life. 5. Clay hypothesis. Some scientists propose that complex organic molecules crucial for life may have formed on the surfaces of mineral clay particles, providing a scaffold for early life to develop. Despite ongoing research, the exact mechanism by which life originated on Earth remains unclear, and the topic continues to intrigue scientists and researchers worldwide. 4. The Fermi Paradox. Fermi Paradox is the apparent contradiction between the high probability of the existence of extraterrestrial civilizations in the universe and the lack of evidence or contact with such civilizations. Several possible explanations have been proposed to account for this paradox. 1. Rare Earth hypothesis. Some scientists suggest that Earth may be a rare and unique place where conditions necessary for complex life to develop and thrive are extremely uncommon in the universe. 2. The Great Filter. This hypothesis posits that there is a crucial step or barrier that makes it extremely difficult for life to evolve from simple forms to advanced civilizations. The Great Filter could be behind the scarcity of observable extraterrestrial civilizations. 3. Self-destruction. It's possible that many advanced civilizations destroy themselves through war, environmental degradation, or other means before they can make contact with other civilizations. 4. Lack of technological advancement. Some suggest that civilizations may remain at a technological level where they are unable to communicate over interstellar distances, or they simply have no interest in doing so. 5. Zoo hypothesis. This theory suggests that advanced civilizations are aware of Earth but choose not to contact us, instead observing us from a distance to allow humanity to develop naturally. 6. We haven't looked hard enough. It's also possible that we simply haven't searched extensively enough or in the right way to detect extraterrestrial signals or evidence of their existence. The Fermi Paradox remains an unsolved mystery, and it continues to fuel speculation and debate among scientists and enthusiasts. It's a complex topic with no definitive answers, and researchers continue to explore various theories to better understand the apparent absence of extraterrestrial civilizations. 5. Quantum entanglement. Quantum entanglement is a fascinating and puzzling phenomenon in quantum physics. It occurs when two or more particles become correlated in such a way that the quantum state of one particle is dependent on the state of another, even when they are separated by vast distances. This means that measuring one particle's property instantaneously affects the other, regardless of the distance between them. This correlation persists, even if the particles are light years apart. The mystery of quantum entanglement arises from several key aspects. 1. Instantaneous correlation. When one entangled particle's property, like spin or polarization, is measured, the other particle's state is determined instantaneously, seemingly violating the speed of light's limit on information transfer. 2. Non-locality. Entanglement suggests that particles can be connected in a way that transcends classical notions of locality. Changes to one particle's state occur without any apparent signal or interaction between them. 3. Lack of hidden variables. Quantum entanglement challenges the idea of hidden variables, which are hypothetical unmeasured properties that might determine the outcomes of quantum measurements. Experiments like Bell tests have shown that certain correlations between entangled particles cannot be explained by hidden variables. 4. Superposition. Entangled particles can exist in a superposition of states until measured, meaning they are in multiple states simultaneously. This adds to the complexity of understanding their behavior. 6. The Pioneer Anomaly. The Pioneer Anomaly was a puzzling phenomenon observed in the trajectories of the Pioneer 10 and Pioneer 11 spacecraft as they traveled through our solar system. It was characterized by an unexplained slowing down in the speed of these spacecraft. Several hypotheses were proposed to explain the Pioneer Anomaly. Some of the proposed explanations included: 1. Thermal radiation. One theory suggested that the heat emitted by the spacecraft's electrical components could have caused a slight recoil effect, resulting in deceleration. However, calculations showed that this effect should have been too small to account for the observed anomaly. 2. Uneven heat emission. Another possibility was that the spacecraft emitted heat unevenly, creating a lopsided radiation pressure that caused the deceleration. This theory had some merit but was not conclusive. 3. Modified laws of gravity. Some researchers considered the possibility that the laws of gravity might need modification at very large distances from massive objects like the Sun. However, this was a highly controversial idea that conflicted with well-established physics. 4. Systematic error. There was also the possibility of a systematic error in the data analysis or instrumentation, but extensive efforts to rule this out did not provide a clear solution. It's worth noting that the Pioneer Anomaly was a long-standing mystery, and new data or research findings may have emerged since my last update in 2021. Scientists continued to investigate the anomaly in the hope of resolving this intriguing puzzle in celestial mechanics. 7. The Moon's origins. The origin of Earth's moon, often referred to as the moon, has been a subject of scientific investigation and debate for many years. There are several hypotheses, but the most widely accepted theory is the giant impact hypothesis, which proposes the following sequence of events. 1. Tear hypothesis. About 4.5 billion years ago, during the early formation of the solar system, a mass-sized celestial body called Theia, or Orpheus, collided with the young Earth. 2. Impact event. The impact was incredibly powerful, resulting in a violent collision that caused both Theia and a significant portion of Earth's mantle to be ejected into space. 3. Moon formation. Debris from this collision began to coalesce in orbit around Earth and eventually formed what we now know as the Moon. Evidence supporting the giant impact hypothesis includes the Moon's composition, which is similar to Earth's mantle, and the fact that both bodies have a lack of volatile elements like hydrogen and helium. Additionally, computer simulations have shown that such a collision could produce the Moon's characteristics. While the giant impact hypothesis is widely accepted, ongoing research and observations continue to refine our understanding of the Moon's origins, and new discoveries may shed further light on this ancient celestial mystery. 8. Consciousness after death. The mystery of consciousness after death is a topic that has intrigued philosophers, scientists, and theologians for centuries. There is no definitive scientific evidence or consensus on what happens to consciousness after death, and it remains a subject of speculation and belief rather than empirical understanding. Several different perspectives and beliefs exist. 1. Materialist view *. Some scientists and philosophers argue that consciousness is a product of the brain's activity, and when the brain ceases to function at death, consciousness also ceases to exist. 2. Religious and spiritual beliefs *. many religious and spiritual traditions propose various afterlife scenarios. For example, Christianity teaches about heaven, hell, and the soul's continuation after death. Hinduism and Buddhism suggest reincarnation, where the soul is reborn into a new body. 3. Near-death experiences, NDEs, ***. Some individuals report having NDEs, where they claim to have experienced consciousness during clinical death. These experiences often include seeing a bright light or having a sense of leaving one's body. However, the interpretation and scientific explanation of NDEs remain controversial. 4. Quantum physics speculations ***. A few theories suggest a connection between quantum physics and consciousness, proposing that consciousness might exist beyond the physical realm. Still, these ideas are highly speculative and not widely accepted. In summary, the mystery of consciousness after death remains unsolved. It is a deeply philosophical and metaphysical question that lacks conclusive empirical evidence. Beliefs about what happens after death vary widely across cultures and belief systems, and the answer to this question may continue to elude us for the foreseeable future.